Oftentimes, when using object-oriented programming, developers find that they have many conditional checks around their objects. Well, some do. Others just run into trying to get property of non-object warnings and ask the internet what's going wrong. This is usually caused by deeply nested object associations, objects that know too much about what their collaborator objects have going on. The law of Demeter is actually quite simple. Though the name sounds intense since it's proclaimed to be a law, it's not what it seems. The law of Demeter essentially claims the four following things. The method on an object is allowed to interact with the following: other methods on its object, methods but not properties on properties of the object, methods on arguments passed into the object, and methods on instances of new objects created inside of the method. Let me show you some of these with code so it makes a bit more sense. In example.php, we have three classes defined. User has two methods, getUsername and getProfile. Profile also has two methods, getName and getPhoto. Photo only has one method, and that's getPath. All dependencies are set via constructor. The chain here is that a user has a profile, and a profile has a photo. If you've ever used an ORM like Eloquent, PHP Active Record, or Propel, you're likely familiar with this kind of nested object as relationships. The law of Demeter should apply there as well. Below, I demonstrate this as a chain as it's instantiated. User is assigned as a new user object, injected with a profile object, that is injected with the photo object. This builds up our dependency graph, and we're good to use it in the example below. If I execute the script, I do get the expected results, so we know all is working well. Okay, so how do I make our user object play nicely with the law of Demeter? Let's start off with something simple on the user object. We'll start with the first rule. A method can interact with other methods on its object. We can address the way we're currently grabbing the user's name on their profile. In our first example, we need to use user, getProfile, getName to access it. This is brittle as is. That's also asking the consumer of this object, whether another collaborator object or a script-like example, to know an awful lot about the user object's internals. So as is, the consumer needs to ensure that the profile exists, and then they may use the name if it does. This is kind of frustrating, and our abstraction is leaking. We're showing our guts to the outside world. Let's create a new method on user to help us clean this up. We'll name this one getName, and inside we'll check to ensure that this profile exists, and if it does, we'll return this profile getName. So now as long as the profile object exists, we'll get the name from the profile object, otherwise we'll get null. Let's update our code at the bottom to reflect this change, and we can delete the extra conditional check, and we can now simply assign name to be username. This is much simpler and gets rid of the ternary conditional since we are guaranteed some usable response is coming back from this method. When we rerun our example, everything remained the same, but the code got a bit cleaner. So how do we tackle this next problem? We're 3 arrows deep in this object nesting. Ideally, the law of Demeter wants you to have one, but that's not a hard fast rule since method chaining is still completely viable under the law of Demeter, but it shouldn't be reaching into other several objects. Let's see how this works by again starting with the user object. Next, we'll create a public method called getPhotoPath on the user object, and then inside we'll do if this profile and this profile getPhoto will return the value this profile getPhoto getPath. Now at the bottom, we'll assign path as user getPhoto and get rid of the extra conditional. Running the example shows us that the output is still what we want, but we aren't quite done yet. Our example is still good, but now our user object is violating the law of Demeter by accessing getPath on a nested object returned from getPhoto on our profile property. So let's fix this by creating a new public method named getPhotoPath on profile. Inside, we'll write that if this photo exists, we'll return this photo getPath. Now if we delete the body of our getPhotoPath method in our user object and start over, we can make an if statement to check if this profile exists, and if so, we'll return this profile getPhotoPath. This is now respecting the law of Demeter, so let's run this again to make sure it's still working. And yep, still looks good. So that's the law of Demeter in a nutshell. It's also commonly referred to as tell, don't ask, because you're telling an object what you want, not asking about what the object knows before getting what you want. In most cases, it'll make the interface of an object much cleaner to reason about, and it'll make the code easier to change. However, as you can see above, it does lead to some extra code that may seem redundant. It does serve a good purpose in its redundancy, and it abstracts the error checking, but it's still some extra code bloat. You never have to follow law of Demeter 100%, but it is still an excellent principle to follow to keep your APIs clean and help your objects interact in a clean, safe manner. So that wraps up this episode. Next time, we'll be checking out some pros and cons of using type hinting over regular duck typing.